Hey guys, it's Dr. Darbro. The purpose of this video is to look at R in terms of working correlation, regression, and residual problems that you guys have been working on. And so I've got a data set here, and what the data set is, it's the height and head circumference of some young children. This data was collected by a pediatrician who wanted to examine the relationship between a kid's height and their head circumference. So the very first thing I did, you can see that we have our data that I'm highlighting for height, and of course we got our data for head circumference. So the first thing I did is I came over to R and I entered the data in this format. First thing I did was give the variable a name. HT seemed reasonable to me. 2 letters, all capital, be easy to access. And then I think I actually copy and pasted the data in the C command, and I did the same thing for HC, which is head circumference. So what I now want to do is I want to run back over to the spreadsheet. I'm sorry, the spreadsheet, but the worksheet, and let's just work through this together using R. Okay? So part A, report the descriptives for both variables. So what I would want to do here, probably the easiest way at least, is to go summary HT. Now summary HT is going to give me a lot of my answers that I need. So first and foremost, the mean is 26.35. It looks like the median is 26.62. Standard deviation I'll have to come back and get later. As with the IQR, I'll also come back and get it in just a second. I could make a subtraction there, but I'm going to do it a little bit easier way. Okay. Next thing I want to do is summary HC. So the mean is 17.42. And the median is 17.45. So guys, let's get the standard deviations. So standard deviation for HT and standard deviation for HC. So the standard deviation for HT is 1.09. Descriptive statistics measures are usually reported to 2 places. And while we're at it, let's just go ahead and get IQR. It's not going to work, right? For HT and IQR for head circumference. So the IQR is 1.31 and the IQR is 0.36. Okay, the next question that we have is prepare a scatter plot and briefly describe its shape. So what I'm going to do here is I'm going to do plot. And the format that we use is our y variable tilde our x variable. Well, in this case, our y variable is HC. And we're trying to predict head circumference from the kid's height. Now, something I can do is I can do semicolon, and add ab line LM HC HT, and I'll actually get my line on my model. So, I'm sorry, my line on my scatter plot. Now this gives you, it helps you a little bit because first of all, it helps you determine whether your relationship is positive or negative. If the slope of the line is positive, we have a positive relationship. Similarly speaking, we have a negative relationship. So I'm going to refer to this as first of all, a linear relationship. It has sort of a straight line pattern. It's definitely positive. And I'm going to go with a moderate relationship. So the 3 things we focus on when describing a scatter plot: do we have a linear or nonlinear pattern? Do we have a positive or negative relationship? And do we have a strong, weak, or moderate relationship? Okay? And a lot more about this information right here. Don't sweat that too much. Just put that in your bag of tricks of something that you'll use when you create a scatter plot. All right, gang, next thing we're going to do is do a correlation coefficient. And it turns out this is really easy. Just COR. Put your X variable first, your Y variable second. It actually turns out it doesn't matter which you put first or second, but just you know, good to get make good habits, I guess. All right, so our correlation coefficient, we can come over here and we can see that this is 0. Let's see, 0.60. And R squared, which is the coefficient of determination, and this is going to be reported as a percentage. Now we want to square this. So this gives us our R value. So gang, we know that our R value is 35.8%. So this tells us the correlation coefficient of 0.60 tells us that we indeed do have a moderate relationship. And the coefficient of determination tells us that 35.8% of the variance in head circumference can be explained by small changes in height. Okay, the next thing we do is we want to create the coefficients of the regression model. So the way we do this, much quicker, much easier than with the calculator. We just go LM for linear model. We put our first variable is our Y variable. And I don't know what I did there. And our second variable is the X variable. So LM stands for linear model. Put your Y variable first, then hit your tilde, and then hit your height. Guys, when you hit this, you're going to get kind of a different look that we get on the calculator, where we get A's and B's, but essentially we get the exactly the same thing. The intercept is clearly defined, but it's a little confusing why height, which in this turn turns out to be the slope, is 0.181. If you think about, and I'll go over here and write this, if you think about the general form, what goes with the X, in this case, which is height? That's the slope. So R has kind of made it a little bit easier, I guess, by putting this value with the height. And so guys, in this problem, I tell you to use the variables of the problem. So let's take this, and our Y variable is head circumference. And that's equal to 12.66 plus 0.18 times the height of the child. So guys, this part right here is the final answer. So let's get rid of the other stuff that we used to create that. All right, part E, make a prediction. So we're going to have the head circumference is equal to 12.66 plus 0.18 times 27.75. All right, so I'm going to grab the calculator for this one. So make the and if I didn't make any typos, I get 17.66. So the predicted value of a head circumference for a child height 27.75 inches would be 17.66 inches. All right, the next thing on the agenda is to find the residuals. And this is really easy to find too. Again, much easier with R than it is, I think, with the graphing calculator. The command that we use for residuals is just RESID. And we have to make the residuals, or create the residuals of our linear model, which again is head circumference tilde over height. Now, I kind of messed up there because as I see now, as I look down to my next question, I'm going to need to use these residuals in a future part of this problem. So I actually need to save these as something. So let me redo that. And I'm going to do capital RESID, which obviously residual. And then I'm going to find these things. And now when I type RESID, I actually get my residuals. Now there's something we haven't talked about yet called data frame. If I wanted to put everything together and see it in a nice, neat data set, I could use what's called data frame. And I could have the height, head circumference, and the residuals in one nice, neat, compact kind of a spreadsheet. This lets me quickly examine that, for example, the number, the fifth kid in this data set who had a height of 25 inches, head circumference 16.85 inches, has a residual of negative 0.33. So again, it gives us a way to look at the x's and the y's and the residuals all in one spot. So let's go back over here. So this is done. Cool. Now the reason we do the residuals in this video is we want to sketch a scatter plot of the residuals over our height. And we can use this plot to determine if a linear model is appropriate for describing the relationship. So from before, we want to come over and do plot. And I want to do my y tilde x. But in this problem, my y are the residuals. And I want to examine that over my x, which is height. Now there's no reason to put ab line on this one as we did before, because we're not going to use this plot to make any predictions. This plot is to examine the appropriateness of the linear model in describing the relationship between height and head circumference. So guys, if I hit return, what I'm looking for is the distinction between, and this is keeping it in the simplest case, but I'm looking for the distinction between random, kind of a shotgun blast, or U-shaped. And guys, when I examine that doesn't look U-shaped at all to me. So I can come over here and determine that the scatter plot of the residuals over height is random, which indicates that a linear model is appropriate for describing the relationship between height and head circumference. So if this pediatrician really is interested in being able, for future kids, being able to predict the head circumference from a kid's height, the linear model that we predicted seems to be appropriate for doing that. All right, gang, I'm done. Have a good one. Later.